So here's our third little video segment. We're continuing with the pattern deny conclusion. Okay, this pattern has premise one being P implies Q, and premise two being not Q. So we have a conditional here. The first one we affirmed the premise was true. Here we deny the conclusion of the premise is true. Our conclusion is not P. So to see that's intuitively reasonable, let's say that P is it is snowing, Q it is cold. So our first premise is the same. If it is snowing, it is cold, but we know it's not cold. We can conclude that it's not snowing. So if one is true and two is true, we can conclude that three is true. Okay, that's deny conclusion. The and it's pattern two. This was video segment 3 and pattern 2. And pattern 3 is I call deny option. So its premise is an alternative, P or Q. Premise 2 is not P. And then the conclusion here. So if I know that P or Q is true, and I know that P is not true, then I know that Q is true. Now, just to be, I could reverse this and reverse the order here and get this other one, or we could just state it P or Q and not Q, therefore P. So if I know one of the two options is not true, I can conclude the other one. So what does an example to make this seem more plausible? Let's say P denotes it is sunny and Q denotes it is cloudy. Then the first premise here is it is sunny or it is cloudy. And here this premise, the second premise would be it's not, oh, well, actually, this is this Q here. It's not cloudy, therefore it's sunny. So if it's sunny or it's cloudy, and it's not cloudy, we know it's sunny. Okay, so that's the deny option. And there's the truth table derivation and the second form, and then here's the logical deduction form of that. Well, let's go on to the fourth one. So I call skip middle. So its first premise is that P implies Q. Its second premise is that Q implies R. P implies Q, Q implies R. And our conclusion is that P implies R. So you can sort of see there's this, you can sort of see that you go from P to Q, then Q to R, then you can sort of get rid of the middle. That's why I call it skip middle. And here's an example that hopefully makes it seem more intuitive. P denotes it is snowing, Q denotes it is cloudy, and R denotes it is dark. So if we know the following two propositions, if it is snowing, then it's cloudy. That's P implies Q. If it is cloudy, then it's dark. That is Q implies R. Then we can say if it's snowing, then it is dark. Because if it's snowing, the first proposition, if we assume it's snowing, this first proposition guarantees it's cloudy. If we know it's cloudy, the second proposition guarantees it's dark. So we know if it's true that it's snowing, then we know that it's dark. Okay, well, that's skip middle. And there, I've left the proposition for you from practice the truth tables. And here's the logical derivation. Actually, it's a little shorter than the previous one, even though the promises look a little complicated. Okay, the next ones are the first four are actually quite useful, and they actually seem, they seem to get you something that you didn't see quite before. And the same thing is with common outcome. But here we have one with three premises. Okay, the first premise is P or Q. The second premise is P implies R. And the third premise is Q implies R. So the structure is we have an alternative, P or Q. The first alternative implies R, and the second one implies R. So that means we know, therefore, that R is true, because if either P or Q is true, but both of those alternatives imply R, R is the common outcome. Okay, here's an example that makes that seem plausible, hopefully. P, it is snowing. P represents the proposition it is snowing. Q, it is cloudy, and R is dark. So if it is snowing or it's cloudy, and you say if it's snowing, then it's dark. If it's cloudy, then it's dark. And you know it's either snowing or cloudy, then you know it's dark. Okay, and then here is lost a little bit of a place here. Let me go back and find that in the table of contents. There was a little bit of a tussle between the graphics tablet pen and my mouse. Common outcome. Okay. There's the truth table. And we can come back to the next. Okay, we can come back to the next number 6 out of 8 of just called choose one truth. Okay, so here the premise, there's only one, unlike this one, which had 3 premises and a conclusion. This one has one premise, P and Q, and therefore we include P. An alternative form is premise 1 is P and Q the same one, and therefore Q. So there's 2 possible premises. So what we're saying is if we know that P is true and Q is true, we can then disassemble that and assume that P is true. Alternatively, disassemble that and assume Q is true. So here's some example. If P represents the proposition is snowing and Q represents the proposition is cloudy, then we know. If we know that it is either snowing, if we know that it's snowing and it is cloudy, then we include it snowing. If we know that it's snowing and it's cloudy, we can also conclude or alternatively conclude that it's cloudy. Okay, so this is fairly straightforward, either using truth tables or using the sequence of logical equivalences. And 6, 7, and 8 are mostly useful as steps in larger arguments, as we'll see. This last one is create alternative, in which it also has one premise, say P, and then you can have the conclusion P or Q, where Q is any proposition. So this is, again, mainly if you wanted to prove P or Q and you had proved P, then you can right away assume this is true. And alternatively, this is a mistake here in the text. What it should be is P1 is Q, then P or Q. And I think, hopefully, on the inference page, we have it right here. X implies premise 1 is X, conclusion X or Y. Premise 1 is Y, therefore X or Y. Okay, that's create alternative. Sort of the opposite of choose one truth. 8. Well, actually, choose one truth is the opposite of create combination, but they're all in some sense simple ones that have sort of limited scope, so to speak. Okay, let's say that premise 1 is P, Premise 2 is Q, therefore we know that P and Q is true. So an example, if P is it is snowing, Q it is dark, then we know that it's true P is snowing and it is dark. It's just a reassembling two separate propositions into an and of both of them. For example, let me take a math example this time. Let's say P was x equals 1, right? And Q was x equals say y, right? Now, if we knew that y was equal to, if we knew that P was true and Q is true, then we would know that x equals 1 and x equals y. Okay, we know these both true. Maybe this isn't a great example. What I was thinking of was, here's an example that shows that, well, this is a valid argument. Here you can make it. You can show that if x was equal to 1 was P and x was equal to 2 was Q, right? Well, each equation individually is okay. This just says x is equal to 1. We know that if we choose the number 1 for x, this is true. If we choose the number 1 for x, if we choose the number 2 for x, this is true. Well, the point is, if this was true, and if we knew these were both true, we can conclude that x equals 1 and x equals true. But this is false because, so this is an example where this is a valid argument. This is a valid pattern, but this is an unsound argument because one of these is false. So it's an example of an unsound argument. Well, that shows all 8 of the, or demonstrates all 8 of these patterns of reasoning, and they're what justify, or we're going to use these to justify individual steps in other arguments or proofs. So we've established these with our truth technology of truth table technology and logical equivalence technology, and now we're just going to try to use these without any appeal or with minimal appeal to logical equivalences in larger arguments. Okay. There are some exercises which you should try, which we would do in class if this were live. That the first one here is, of course, all the exercises in the text are assigned, not necessarily to turn in, but to check your understanding. So, for example, here you're given propositions. Peter's a dragon, Quincy is a cat, rubies are red, and you're supposed to just write out the logical equivalence here. It says if Pete's a dragon, then Quincy's a cat. Pete's a dragon, therefore Quincy's a cat. It's just writing out the pattern for a firm premise so that you become familiar with these patterns. Okay, then it goes the other way. Here's some statements, and this is one which there are exercises in Reg X in which I give you a statement and you're supposed to identify whether it's one of these 8 propositions, and if it's not, to write invalid. Okay, so for example, here, Frodo is a hobbit, therefore Frodo is a hobbit or a thief. Well, this is an example of the create alternative pattern. And you go through and do these. Again, that should help, these first exercises help you to become familiar with these 8 patterns. Now, this one there's other patterns, but there's also possibilities for patterns that aren't true. This one says, how do we know this is an argument pattern is valid or not? Well, we could say P implies Q, P implies R. Those are premises. Does this mean that P implies Q and R? Well, one way to show that this is or isn't a valid rule of inference is to fill out this truth table and then see, because we can know, we can see from P, Q, and R all the possible truth values, all the possible worlds or situations in which P, Q, and R are true or false, and then right here whether P implies Q is true, whether P implies R is true, and then here whether we can figure out from these one from second column, that's a typo there, the second column Q and R, whether that's true, and then comparing the first column with that, and we can decide what the conclusion is true. And then so, but the question is which rows in this table are relevant for determining whether this is a valid rule of inference. Not all rows are relevant, because if both premises are false, or if one of them is false and one of them is true, it doesn't matter what the conclusion. It doesn't tell you anything. It's only the rows where all the premises, in this case, both premises are true. Then in those rows, you look and see if all the conclusions of those rows are true, it's valid. If any single row with true premises as a false conclusion is invalid. Okay, here's another example of that. So those are just basic exercises that help you understand whether you understood the material and to assimilate it. Now, um, let us go to another video segment.